which leads to, I guess, this. Gary Lezak, who is trying to make headway in this very, I guess, field of finding trends, finding ways to answer these questions that we thought maybe we'll discuss them in brainstorming fashion. But Gary's going to be here to talk a little bit more about accurate long-range weather forecasting. Gary, glad to have you with us.
Good afternoon, everyone. Everyone doing good? Yeah. Let's begin with numbers. 1 hour from now, this conference will be over. And let's give the organizers a big hand for this great week we've had. 13 hours and 20 minutes from now is the summer solstice. 13 hours and 20 minutes. So today is the last day of spring. Isn't that exciting? 57 days from now, the weather pattern will look like today's weather pattern. 57 days ago, the weather pattern looked like it does today. And that's how I'm going to finish my presentation here in a few minutes. In 30 minutes, I'm going to be introducing you to a new weather forecasting technology. It's called the LRC, and I hope to open your mind to what is going on. All right, let's get started. What would you do if you knew what the weather pattern was going to look like 50 days from now, 100 days, 200 days from now? Well, maybe we'd make some accurate long-range weather forecasts. Now, how accurate do you think these forecasts would be? My talk today is really based on a Super Bowl weather forecast that I made. 4 weeks before the Super Bowl, I put out a forecast. Talk about the pressure of putting out a forecast. You got a forecast for a week from now. You're going, there's a chance of snow, and then you say there's no chance of snow, and you go for it, and there's a lot of pressure on getting that right. A lot of forecasts came out for the Super Bowl predicting major snowstorms, Arctic cold, and my forecast is about to be completely contrary to that.
So let's take a look at some of our recent successes. Weather 2020 LLC, my weather company, has made these accurate forecasts, big forecasts, accurate forecasts for the Super Bowl 4 weeks before, the Masters Golf Tournament forecast, 60 days before the Masters Golf Tournament in April. Weather 2020 put out a forecast and a press release saying that it would rain in the early rounds, and then it would warm up and become quite nice for the main tournament. They had their first washout in 11 years on the Monday of the tournament for the practice rounds, and then it ended up being absolutely gorgeous. The Kentucky Derby, we made a forecast 60 days before, predicting a dry track, and it was a perfect day. Arctic outbreak and 4 storm system 60 days before. We issued that forecast for our Weather 2020 clients, our winter clients. More on that in a few minutes. And the severe weather setup forecasted 120 days before. 120 days before. We made a forecast for the severe weather, and not just making a forecast, we showed why and which dates they would likely happen, like issuing a severe weather outlook, not just 4 days to 8 days before, but 120 days before the severe weather setup. And it happened. We've issued 30, 60, and 90-day forecasts for that. 26 documented 15 to 200-day forecasts since December 1st have been made. 20 of them have been accurate, 76.9% accuracy. And the ones we were wrong on, all 6, were just off by 2 to 3 days, maybe 5 days. So the weather pattern returned, we just made an inaccurate forecast only a little over 20% of the time. So the Super Bowl forecast, we put a press release out, Weather 2020 made this forecast, and a New Jersey.com, NJ.com reporter picked up on it and did a whole article, and you can see it. In our press release, and he picked up on it, we said, weather predicted to be unseasonably warm and no chance of snow in the Super Bowl. And he writes, file this one in the category of wishful thinking, especially for those with tickets to this year's Super Bowl in New Jersey. One long-term weather forecast predicts that there will be no chance of snow on February 2nd in East Rutherford. Even better, it'll be warming up into the 50s. And this was not just a statement. We were using the 57-day cycle that we believe was established and to this day continues. And we made that forecast as other forecasts such as Farmer's Almanac predicting brutal cold and a major snowstorm. And you'll see why AccuWeather and other forecasters picked up on the possibility of snow. But it didn't happen. What happened on Super Bowl Sunday? There's a picture of the Empire State Building. Absolutely gorgeous. Right before kickoff, it was 54 degrees. My goodness, what a beautiful day. Even that morning, the forecast was for a high in the upper 40s. So our forecast 4 weeks before was better than the forecast that morning from the National Weather Service. For our clients, Weather 2020's clients, we have some winter clients, including Peak Resorts and Compass Minerals. They mine and distribute salt. On December 9th, we put out this forecast. An Arctic blast will likely affect key locations in late January into the first 10 days of February, with 3 or 4 snowstorms hitting their key locations, such as Toronto and Buffalo and Chicago. It happened. There was a major Arctic outbreak, and all 4 winter storms hit. So they let their customers, such as Home Depot, True Value, Ace Hardware, let them know about the potential for the winter storm. They prepared, they ordered more salt, and this company's having a banner year as a result. So our forecast, a 60-day forecast, accurate. Once again, not just a statement, based on the weather pattern that is cycling. The 120-day forecast, we said that there would be severe weather between May 3rd and May 12th. Confidence is high. The weather pattern that produced the November 16th and 17th outbreak of severe weather through the Ohio Valley back into the upper Midwest and Great Lakes states would be returning. And we showed why, we showed how, and it did. Yes, anytime between May 3rd and May 12th there might be a severe weather outbreak, but we show why, we give confidence on why, and then as we get closer we narrow down the dates. So the Storm Prediction Center has their experimental products, as we saw earlier in the conference, of their day 4 to day 8 outlooks coming out. We can do it 120 days out. Here's an outlook. Look at the top graph shows our forecast, Weather 2020's forecast, 45 days before, made in mid-February for early April, mid-April, and late April to have the best chance of severe weather through Tornado Alley and key locations. The bottom graph is the Storm Prediction Center. Notice how early April, mid-April, and late April, a verification of a 45-day forecast. We are able to do this using the cycling weather pattern. So accurate long-range weather forecast. Were these forecasts luck, skill, or a little bit of both? The weather pattern is cycling regularly, and these forecasts are based on the LRC. So let's talk about cycling weather patterns. You may have heard about the Madden-Julian Oscillation, the MJO. It describes tropical convective complexes that have been shown to be cycling across the tropics. In 1971, Roland Madden and Paul Julian stumbled upon a 40 to 50-day oscillation when analyzing zonal wind anomalies. The MJO, also referred to as the 30 to 60-day oscillation, turns out to be the main intra-annual fluctuation that explains weather variations in the tropics. The MJO shows accurate forecasting of this variability will benefit people. Accurate forecasting of this variability will benefit people living in the tropical regions and also over the rest of the Earth due to teleconnections between the weather in the tropics and weather elsewhere around the globe. An individual MJO event can last anywhere from 30 to 60 days, and this affects monsoons, hurricanes, the South Convergence Zone, and possibly other teleconnections. Dr. Madden himself, and I've been in contact with him this year. We've had some email exchanges, and he's been really nice. He's come up with some ideas. But he says, another thing I hope that you get from my description of the MJO in the tropics is its huge scale. Its very large spatial scale disturbance. Even though after 30 years we still don't know exactly how it affects the mid-latitudes, it's so big in the tropics that it's got to affect the mid-latitudes. And you can go to the site, as you can see on the address there, meted.ucar.edu/climate/MJO. Great module in there about the Madden-Julian Oscillation. And Dr. Madden's even come up with a couple ideas on how the LRC might be generated. Perhaps the upwelling of water in the northern Pacific and northern Atlantic in the fall. And he says another important aspect is its time scale, and it's got a sort of an average of 45-day period, which means that it may help in, say, 2 to 3 week forecasts, and maybe even slightly more than that, 120, 200 days perhaps. So cycling weather patterns, the MJO, an accepted theory describing cyclical tropical convection on the order of 30 to 60 days. My hypothesis, the LRC, describes a weather pattern within the westerly belt, 35 to 75 day cycles. Most years are in the 42 to 60 day range. It is likely all tied together. If the MJO is accepted, why not the LRC? The cycling weather pattern that I believe we are all experiencing this year has been close to a 57-day cycle. So I want to go over with you today exactly what this is all about and how we made that Super Bowl weather forecast that was spot on. We didn't just make a guess, we used the LRC. So what is Lezak's recurring cycle? Meteorologist Jeff Penner, the best weather forecast method known in the field of meteorology today. We are making these forecasts without the need for a computer model. A unique weather pattern sets up every fall between late September and early November. So a new pattern will be setting up this fall. And every year is unique. Every year is different. There are no 2 years that are the same. And that's what's so fascinating about it. And I think you would all agree this past year has been a unique and unusual weather pattern. The pattern then continues through the rest of fall, winter, spring, and deep into summer. A cycle length is determined, and this allows our weather team to make these accurate weather forecasts. These long-term, long-wave troughs and ridges develop. They allow us to pick out the most likely spots to have the worst weather. And this year's cycle length is 55 to 61 days, specifically 56 to 58 days. On our site, Weather 2020, we've shown dozens of examples of the cycling pattern centered on right around 57 days. So how do we make that accurate forecast for the Super Bowl? Let's take a look. Look at the weather pattern that happened on Super Bowl Sunday. Notice the southwest flow. We're looking at the 500 millibar flow, about 18,000 feet up. Notice the southwest flow over the East Coast, and then you have an upper level low off the California coast, cross-polar flow, and a whole big trough trying to evolve and develop. This is the pattern on Super Bowl Sunday. We had high confidence that the weather pattern would look like this, as it already happened in the previous cycle. So we forecasted a warm-up into the 50s and no chance of snow in the Super Bowl. But look back to December the 7th, 57 days before. You have the southwest flow on the East Coast, the upper low near the West Coast, and the cross-polar flow. The same pattern, but a little bit different. Storm dropping to the west. So there's the pattern on Super Bowl Sunday, and the similar pattern just 57 days earlier. And that's how we made the forecast. Now, what's fascinating about this, you see the two patterns and how similar they really are, is that we know the pattern's going to look like this. We now know. There's the two patterns side by side. Now, the GFS model, the European model, and other computer models start coming out 16 days before any event. They go out to 384 hours. And let's look at that GFS model days to weeks before the Super Bowl Sunday in our forecast verification. One computer model, the first one, GFS, you get to about 348 hours out, 15 days out. Look at that huge trough in the eastern part of the country. Huge trough. We know that that computer model is wrong. I slept easy that night. Big ridge in the west? No. Big trough in the east? No. There's supposed to be southwest flow on the east coast. With that pattern, there's no way it's going to warm up. Look at that pattern and look how it's supposed to look. On December 7th, we knew the pattern would look more like this, not like what the GFS model or other models are predicting. And when this forecast came out, the Farmer's Almanac AccuWeather, other forecast outlets, maybe even you, thought, wow, it's going to be brutally cold. Look at that. There's no chance of it being in the 50s. And this computer model was wrong. Using the LRC, we know it's wrong. And we can tell you when it's right. 252 hours. Now we're 10 to 11 days out. Once again, a trough in the east, not southwest flow. It sort of has the upper low, cross-polar flow developing. And the pattern's starting to get picked up by the models, but it's still wrong. In this scenario, there would be, for certain, a cold outbreak again in the east and possibly some snow. And that's what the model predicts at the surface. This is a surface, and that is cold, very, very cold on Super Bowl Sunday, and snow likely. Not even a chance of a warm-up. There is no way you can predict a warm-up if you believe that model. Now we're 3 to 4 days out, 108 hours out. Out on the west, it's not even right, but it's starting to get that look of the southwest flow that's supposed to happen on the east coast. But even with this pattern, we're 3 to 4 days out, 108 hours out, and I still know the model's wrong. That would still be cold, no chance of it being in the 50s or 40s or 30s for that matter. That's a cold weather pattern, as cold as it was. So if you go back to December, leading up to December 7th, we had this pattern at the surface caused by that upper level wind pattern. We had a warm front coming towards the east coast. This was allowing for a warming surge to be coming out of the southeast into the northeast on December 5th as this pattern set up. Go to the day before the Super Bowl, same pattern, southwest flow, and the warm-up happened. Now our forecast wasn't perfect. We almost got unlucky. It did snow just a few hours before the game, or a few hours after the game. Remember, we did include that possibility in our forecast. We said it could snow a day or two later. In the first cycle, back in December 8th, the day after December 7th, remember that Lions-Eagles game where 6 to 8 inches of snow fell during the game? Look at this. In the previous cycle, it did snow just a day and a half after the warm-up back in December. Based on this, we predicted that it could snow again. It would snow possibly again, and it did, 8 hours later. Here is the setup for the overall weather pattern. As you look at December 6th, this is now December 6th, using the 56 to 58 day cycle. We knew that the southwest flow was going to develop. December 8th, there's a big trough. That big trough in the western part of the country formed a major winter storm. This is after that snowstorm in that NFL game. But that was a major winter storm that happened in each cycle. Now here is February 2nd and February 3rd and February 4th. There's that same major trough. So once again, as we've showed you, there's December 7th and Super Bowl Sunday. And then just a day or two later, we have the same comparison. And it's not just these 2 days, it's the entire weather pattern that's cycling. There's the two troughs. We made a prediction for a storm in Kansas City 4 weeks, 5 weeks before, and that verified. That's one of our verifications as well. So a 57-day cycle, that's how we made the forecast. No snow, temperatures in the 50s, and from that same New Jersey reporter, while he's walking around the Super Bowl, he says, I usually despise weather forecasters, but kudos to Weather 2020 for getting this forecast spot on. A tweet from that same reporter who remembers his article from 4 weeks earlier. So there's the weather pattern. How about today? As I'm talking today, I was putting this presentation together. Let's look at the last full day of spring, June 20th. See this weather pattern? The upper level low in the northern plains, the trough off the west coast, the trough off the east coast. See these features? Look at that. This is the 500 millibar flow today on June the 20th. Unusual weather pattern, right? Could it possibly have looked like this just 57 days earlier? Look at this. Here's April 24th, and here's the comparison. You have the trough, you have the trough of the west coast, And the other feature, even that skinny ridge in Canada, it's the same pattern, another example. Now our applications, as you can see here, we have 12 weeks of forecasts on our Weather 2020 app that have been accurate, very accurate. We make forecasts for the entire United States. Eventually we'll do it for the whole world. Weather 2020 is making forecasts for weather-sensitive businesses. And here's a forecast that you can look at. A colder than usual summer pattern is setting up for the Great Lakes region. If you have plans to be in Milwaukee, Chicago, Indianapolis, Detroit, Cleveland, or Cincinnati this week, temperatures will run below to much below average. So test me on this one for the first 2 weeks of July as this pattern cycles. These are the forecasts that we have that only exist here, a whole weather discussion. So there you go. We're also making forecasts for weather-sensitive businesses. Any questions?
Alan.
What are you seeing outside of North America, or are you looking outside of North America?
The pattern I'm talking about that's cycling is in the westerly belt, but really it goes from the polar easterlies all the way down the tropics, and it's cycling all around to the UK, back across Asia, and back around. So that I haven't studied it, I haven't forecasted for Europe and Asia yet, but it's all, the cycle length, I imagine, is exactly the same in each location, especially within the westerlies. Might be a little bit different in the polar easterlies, and when you go down to the tropics, there may be a little bit of a difference there. And there's also a cycling pattern in the southern hemisphere too.
Have you found that it works more effectively in the eastern half of the U.S. and the west? Where do you do most of your long-term forecasting?
Well, as you can see, I've got on the app every location in the United States. And here's what's challenging. I am manually, with my business partner Jeff Penner, we are manually putting all these forecasts in. Now they're regionally done, so if you click on Omaha, Nebraska, or you click on Kansas City, you're going to get the same forecast, but with different average highs and lows. But for the West, it works just as well.
Okay, because I was just comparing not only the two railway maps, which had some, at least for us in this area where I forecast, I come up with two very different forecasts depending on which one I use. And I think you gave us this presentation several years ago, and I downloaded your information, kind of clicked off at least around here, and it didn't seem to be effective, at least in my market.
Right.
I was wondering if there's a difference.
I think it's very effective in your market. The problem for I call these things long-term, long-wave troughs and ridges. And this year, California and Nevada, the tremendous drought that's going on, you have not been near any long-term, long-wave trough. And when you're not near one of those, there will be more chaos around you as the features organize and drop into these long-wave troughs. That's why they become big storms in the same spots all the time. So next year, if there's a weak El Nino or a moderate El Nino, there's more likely to have troughing in the west. And perhaps you'll be, if the LRC sets up in a good spot for you, and you combine that with El Nino, then you'll know you could be in one of those southern United States locations for tremendous rain this winter. But it depends on that. We've learned this in this presentations earlier this week. Last 25 El Ninos, 25 different patterns. 25 different patterns. El Nino is just an influence of what I think is a much bigger thing going on. And so depending on how the pattern sets up, you get a different one each time.
Is there a certain, when do you know, I mean, there's got to be a certain period that you feel uncomfortable with the accuracies in late summer and the fall. Where does it end, and how do you know when to start seeing the patterns we kick off in the new cycle starts?
Well, I've had the app out for just this season, so when we get to September and October, it's going to be very challenging for that. I'll be using the old cycle. Maybe I'll identify the new cycle earlier. A storm in the old cycle will also return in the new cycle, but at a different time scale and in a different configuration. The good thing about these forecasts that I'm making for businesses and for these 12 weeks of forecast, that forecast was made 12 weeks, well, 8 weeks before now, July 6th, but it was made 12 weeks before July 6th. Once I make the forecast, I don't have to change it. It's either going to be right or it's going to be wrong. So I don't have to change. I don't have to spend every single day writing every one of those forecasts. Once it's out there, you just have to update week by week. And then what did you say again?
How do you know
So in September and October, completely limitations to what I do. Okay, there's no way I know October 1st what the pattern is yet. I don't think you can find that out yet. A brand new long-term long wave troughs and ridges set up in the next 30 or 40 days and become established. Then they're there. So by December 1st, you see the repeat. And then it could be 45 days next year. It won't be 56 or 57, 58 days. It'll be 45. I've noticed in El Nino years and La Nina years, it's 42 to 48 days almost always. The last one, though, was 51, so you guys still have variation. But once you identify it, you make accurate forecasts all the way into September. But yeah, there's about that 40-day gray area.
Have you published anything?
Not yet.
Why not? You've been doing this.
I know, and that's what I'm getting advice from everyone, including my biggest critics on my blog. When are you going to have the peer-reviewed paper? So I'm planning on writing something for at least a couple of different publications this year. I'll do it.
What's your hypothesis for the periodicity? This general range of 45.
Well, it might be related a little bit to the MJO. The MJO, those tropical convective complexes are cycling 30 to 60 days. I do believe the cycle length is different from the tropics to the westerlies. And exactly how it happens, I'm not so sure. Dr. Madden had a really good idea talking about maybe as the weather systems start coming south in September and October, they start stirring up the North Pacific and North Atlantic waters, and somehow the pattern starts evolving. I don't know how it's related. I think there's a big river of air flowing above us that's cycling, and yes, the oceans are a big influence, but there's also something very big above us, too. I think that this is independent of climate change because the pattern's always cycling. Climate change is going to be on the order, of some other factors. So the jet stream might be a little bit farther north, or as we've seen with some of our talks, more blocking and weaker, polar jet streams. But overall, the pattern just continues to cycle. So I don't think it's a factor.
If you get a Rex block or an Omega block, will that gunk the system up, or can you tell what will have a Rex block forming 50 seconds?
That's really complex. We got the Arctic Oscillation, the North Atlantic Oscillation, all the different teleconnections that might indicate when we'll have blocking, when we won't. But when there's a big block that develops, I wouldn't say I can tell you when there's a chance of that happening. But when it does happen and the pattern gets blocked up, somehow, some way, I know this is ridiculous, but the pattern seems to have a memory. A storm gets stuck for 5 or 6 days, and then when it comes out of that block, it realigns and gets back into its cycle again, and then 57 days later, it's back again. It's sort of incredible. And I'm sharing it with you guys today. How many of you believe it? Raise your hand if you believe this is possible. Raise your hand if you think there's no way. Oh, you chickens.
We look forward to your peer-reviewed work.
Okay. I'll work on that.
Gary, I have some viewers in my area that follow you on the web and have tried to self-teach themselves some of these, and they're unaware of some of the gaps that you were talking about in September and October, and they try to do a winter forecast in September and October, and I didn't know enough about what you were doing to tell them, let's wait a little bit. But do you run into problems with hobbyists trying to recreate what you're doing?
Not really. It's really sort of underground. It's not, if someone wants to help me take this out of the underground, that's what I'm sort of working on right now.
Are you
But
familiar with some of these hobbyists?
yeah, I've seen some of the blogs. When a forecast comes out in September or October for the winter, and a lot of them do, there's no way. The pattern is not set up yet. We have a brand new pattern that is just now evolving. So any winter forecast that comes out before, say, October 15th for sure, no chance. That's totally based on nothing. I don't know how they make those forecasts. So, and then for me personally, on the air, my boss goes, "Hey, Gary, your winter forecast is going to be November 10th. I go, "No!" So I always try to wait till the last week of sweeps. They want to do it during sweeps. It's actually been tremendous. The highest rated sweeps piece the last 3 years has been my winter forecast night. So, and it makes the rest of the news department all mad. But I try to wait. But when I put out that winter forecast, I'm not even comfortable with it until about December 10th. I really would rather wait till about December 10th to issue the winter forecast. I know that's a long time. Winter's already starting in many spots, but that's when I believe we can make an accurate one. Whereas beforehand, my first forecast is often got all kinds of errors in it, and I update. And then when it comes to long-range weather forecasting, guys, and I know we got one talk left, we'll be done. But when it comes to long-range forecasting, it's very difficult. If you make a wrong forecast, tonight on the air, tomorrow you get to do it all over again, and you can make up for it, and the viewers go, "Oh, you got it right." If you make a wrong long-range weather forecast, you might have to wait 3 weeks before you verify again. So it's very challenging. Well, hey, I'm out of time. Thank you very much, and let me know if you have any questions right now.
And if you do want to learn more, I did go ahead and tweet out some links and also some educational links about the MJO as well. If you're not as familiar with these longer term recurring cycles, anyway, or it's a good refresher. It's been a while, maybe since some of you reviewed that. I think it's only appropriate that we close out this broadcast conference with the future, and that is this kid and what he represents. And it's been such a privilege to have you here with us, and he gets to speak his second time during this conference. And thank you all for sticking around and being a part of this. And after he's done, we'll talk a little bit about next year briefly. Okay, Matt.